With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
According to question, an infinitely long straight wire carries the current I1 as the shown in the figure. The total force on another wire CD of length L, which is placed so that C is a distance of A from the current carrying wire. So the force on the wire CD is mu naught I1 I2 upon pi n ln A square plus L square upon A square. Then we have to find the value of n. Okay, so first of all we will find the force on that wire. So according to that is the wire of infinite length, and the current is I1 in that wire. Okay, and the distance from that point is C, and the length of wire CD is L. Okay, and the current is I2. Now we have to find the force in that current carrying wire. So as we know that the force on current carrying wire will be equal to F is equal to BIL sin theta. BIL sin theta. I is the current through that wire which is placed in a magnetic field, and B is the magnetic field due to that wire carrying the current I1. So magnetic field due to any infinitely long wire is equal to mu naught I upon 2 pi r. Okay, so we will use these two formulas. Okay, so first of all we will take a element on that wire CD. So let's assume that is the wire CD. C and D. Assume that x equal to 0. So in that condition, that is the x is equal to L. Okay, and at a distance it is a wire that is carrying current I1. So let's assume that is the element which has length of dl. Okay, that is the element dl, and that distance is equal to L. Okay, assume total length is capital L. Okay, and that distance from that wire is r, and it is making angle phi. Okay, that is the reference line. That angle is phi, and that angle is d phi. Okay, so in that condition the point C makes angle 0 and point D make angle phi naught. Okay, the total angle is phi naught. Okay, and the distance is r. So first of all we will find the magnetic field at that element, that is B1, due to that wire. So B1 is equal to mu naught current in that wire is I1 mu naught I upon 2 pi r. Okay, that is the magnetic field at that point. Okay, so the r is distance. So from the triangle we can find the relation of r and phi. Okay, that angle is phi, and that is distance is r, and that distance is a. Okay, so from the triangle we can see that uh, cos phi is equal to a upon r. So in that condition r is equal to a upon cos phi. Okay, so we will get the value of magnetic field B is equal to B1 is equal to mu naught I1 cos phi upon 2 pi a. Okay, and the direction of that magnetic field B1, okay, direction will be that. Okay, that is the B1. Okay, so that angle is phi, that angle is 90 minus phi. Okay, so that is the phi. Okay, so now force and that element df is equal to current I2, magnetic field B1, length dl, angle sin phi. Okay, so value of I2 B1 is equal to mu naught I1 cos phi upon 2 pi a sin phi dl. Okay, now we have to find the relation of dl in form of phi, means angle. So in that triangle, okay, we can see that tan phi is equal to L upon A. It means L is equal to A tan phi. Okay, so when we differentiate both sides, dl over d phi, we will get A sec square phi. So dl is equal to A sec square phi into d phi. That is the value of dl. So we will put that value of dl in that relation. So we will get df is equal to, okay, mu naught I1 I2 upon 2 pi a cos phi sin phi into sec square phi d phi. Okay, so the df will be equal to mu naught I1 I2 upon 2 pi a. So cos phi will be removed from that relation. We will get sin phi upon cos phi, that is tan phi into d phi. Okay, so we will find where magnitude of force by integration. So F is equal to mu naught I1 I2 upon 2 pi a. Okay, integration of tan phi d phi. Okay, so the limit of phi, okay, limit of phi is from phi is equal to 0 to maximum angle of phi naught. Okay, so 0 to phi naught. So the integration of tan phi, integration of tan x dx is equal to ln sec x. Okay, so we will get f is equal to mu naught I1 I2 upon 2 pi a. Okay, tan phi. Okay, one more thing we missed here, that is the value of a. Value of a will be multiplied, that remove the value of a in denominator. So we will get tan phi, integration of tan phi is ln sec x. Okay, limit 0 to phi. Okay, so sec 0 is equal to 1 and the integration of 1 will be 0. So mu naught I1 I2 upon 2 pi will be equal to ln sec phi naught. Okay, from that triangle we can find the value of sec phi. Sec phi is equal to, that is the value a, that is root of a square plus l square. Okay, so sec phi is equal to root of a square plus l square upon a. Okay, so the value of f is equal to mu naught I1 I2 upon 2 pi ln root of a square plus l square upon a. Okay, we can also simplify that relation, that I2 I1 I2 upon 2 pi ln. Okay, that is root of a square plus l square upon a square. Okay, so that half will become ahead, so we will get mu naught I1 I2 upon 4 pi ln a square plus L square upon a square. Okay, according to question, the magnitude of force is given as mu naught I1 I2 upon n pi ln a square plus L square upon a square. Okay, so by comparing that relation, we will find the value of n is equal to 4. Okay, so our final answer is 4.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.